Hi everyone, I'm going to show you how to use a program called tinycad to make nice looking circuit diagrams for your lab reports. You want nice looking circuit diagrams so you don't have these funny things drawn in by hand. So first thing I'm going to do is I'm going to look up the program. It's called tinycad. On my browser it pops up right away. So if it doesn't pop up on yours, you go to the URL I put on Fun6, and then this is the website from which you can download it. So you click on download, and then when you get to the other site, they'll give you a green download button. It's one right here. I'm not going to click on it because I already have it downloaded and installed. So you click on it, you agree to whatever they ask you to, you sign away your life, you tell them you're not going to misuse it, and then you have it. And once you have it, you open it. So this is what it looks like when you open it. There's a batch of libraries on the side which have components in them. These are a lot of electrical components. And over here, there's a main screen where you're going to draw things. So I usually maximize this window so I can see it better. So I click and I drag. Of all these electrical components, 99.99% of them are not very useful to us because we're not going to be building them, at least not in Physics 1. The things we need are batteries, light bulbs, and resistors. So go to the library called Passive and click on the passive, open it up. Here's a battery. If you go down, you recognize other stuff like, fuses and cells. That's a single battery cell. Lamp is what we're going to use for the light bulb. And then there's a whole batch of resistors later on. That variable resistor is right here, by the way. So let's build a simple parallel circuit with a battery, a light bulb, and a resistor. So let me start with the battery. I click on the battery and it gives me the symbol down here. If I click on the one down here, it gives me something that I can move over my drawing screen. So you see a kind of ghost of what it would be once you put it on. What it does have that I don't like are these references where it says battery B ? So let me turn this off. I'm going to turn off the B ? by unclicking that. I turn off the parameter value by double clicking, or I think triple clicking this. And now it's still in this funny orientation, that electrical engineer orientation. So let me turn it into physicist orientation. So there we go, there's my battery. Let me just click, and there it is. Let me add some more stuff. Let me add my light bulb. So here's the light bulb. Again, I click. I turn off the references by unclicking, turn off the parameter by triple clicking, and then I lay him down here. Resistor, same thing. I have a variety of resistors to choose from. If you just use this one, that's the silly European style resistor, which doesn't look like it resists anything. So let's be Americans about it. We're going to use the American resistor. I didn't click on it, which is why it didn't show up. So now I click on it. Again, references, bye-bye. Turn it and orient it here. If you are actually using this program to make a design that you wanted a company to build for you because you just designed a really great new electronic component, you would leave the references, but we're not doing that. So now I have the three components I'm going to use. Now I want to add the wires. This is fun. The program does it for you. So I go up here and I click on the wire tool. And then as I hover the wire tool over the ends of any of my components, a little circle pops up. What that little circle means is that it recognizes a component and it can add the wires for you. So I just grab it and I pull it, and it recognizes the end of everything. And if I pull it up here, it's going to snap right onto the battery. And if I pull it up here, same thing. You can have a lot of fun with this. Woo, woo. Ultimately, though, you do want it to look like a circuit. Okay, so that looks like a circuit. Let me add a value or two. I mean, I do want to give things some names. So let me say my resistor is, 5 ohms. So over here on the A, I can add a label to it. Let me call it 5. The fonts I have are kind of limited. So I don't have a Greek font, so I can't put in the omega. So I have to type out the ohms. You'll notice that it's green by default. If you want to change it, go ahead. Doesn't really matter. You're probably going to be saving it as black and white anyway. Then you just bring it under the resistor. So that's it. Those are all the things you need to know to make nice circuit diagrams. If you don't like the way yours turned out, like let's say you don't like your light bulb here, you want to put it here, or vice versa, there are a few things you can do. Up here is the edit button. If you click on that and you grab something, you can move it around. Woo! Woohoo! Swinging battery. You can also delete things if you don't like them. I don't like my light bulb all of a sudden, so I'm going to click on my light bulb and X, delete, bam. I'm going to put it back by Control Y-ing. Oh, Control Y shortcut doesn't work. Okay, so now I need to put in a new one. Might as well put in a resistor. Why not? And you guys will notice something that's also kind of nice is that if I have wires in there already, it automatically knows how to snap them into the grid. So there we go. That's the circuit diagram. I can make it a little nicer, but that's good enough. Let me show you how to add it to a lab report. So first I'm going to save it, except I don't want to use save or save as. If I do that, it saves it in this funny proprietary format, which you won't be able to open in Word or any other program. I'm going to export it as an image file. The options you get are either a color bitmap or a black and white bitmap. I normally use the color bitmap, so it doesn't, notice the obnoxious thing doesn't tell you where it's saving it as. If you go to browse, you can find out where it's going. I'm just going to put it on my desktop so I can find it. So there, I saved it on my desktop and click export, and there it is. Let's find it. Okay, so here it is. Here's the output. Let me open it up. Oh, what is this? It's so tiny. And what is this funny thing down here? This is because if you're making a real schematic, that's a fancy name for circuit diagram, you will have information like who made it, what's it going to do, what other schematics is it connected with. We don't need all that. All we need is this part over here. So I normally just open it in Paint, and then I select the part I want and then crop out the rest. And then I can also save it as a JPEG. And if I save it as a JPEG, that's something useful that I can put anywhere. So I don't know, I'd call it Circuit 1. And now it's in a format that I can use in my lab report. So if I open Circuit 1, there we go, nice and neat. And you can even edit it some more in Paint. So that's how you do it.